on a very important topic for any reliability program, and that's asset criticality. Because understanding what the criticality of all your equipment processes and all your equipment are is a very important part of, it's kind of the baseline of your reliability program. So we're going to just go over these slides here today and see if we can help you out with your processes in this area. Again, a little bit about myself, and I think most of you have seen this over the course of the last few webinars. We're not going to spend much time on this, but all the things we do as a company here are shown on this slide, and you guys all, of course, will get a copy of the PDF and have a recorded copy if you want it. So again, risk of failure. This is kind of gets into the part about asset criticality. You know, it says many companies and industries have benefited from using the process of asset criticality. You know, with the potential for major accidents, death, property loss, and environmental impact. This process of equipment ranking and asset criticality is very important for us to understand, so that we develop procedures and processes. We put processes in place so these major incidents don't happen. But how do you calculate the risk and the cost of failure? It can be very difficult. Lots of factors to consider. You know, sometimes it's just the time of the year. Sometimes it's the rate that we have to maintain, the rate we have to run. Sometimes the cost of risk and cost of failure is around safety. You know, sometimes what is it the cost of repair? You know, there's lots of repairs in your plant that are small. Other repair costs are very large, or how much downtime you're going to have. So there's lots of things you want to look at when you look at, you know, what is the risk of failure? What is the risk of a failure? But a good asset criticality, good asset equipment criticality can be a good method to help us do this. It helps us look at all these factors, and that's what we'll talk about as we go through these slides today. What are some of these factors that we really need to understand when we do an asset criticality? You know, a customer of mine in Canada, you know, I went up there and they said they did their asset criticality, but they just did it with maintenance people looking at one factor, you know, what can fail to cause us to be down. Well, there's other factors we need to look at. But again, if we go back to our PF curve, we want to make sure when we move away from these things on the right side of the curve, where we're doing things based on finding things with human senses. Climb up this curve, and we want to do more predictive technologies. And then we get over to our proactive steps, and I know I've got them listed in not any order of importance, but you know, equipment criticality, asset criticality, how you rank your equipment is a very important tool and a very important process to develop all the things that are going to happen around this curve. So this is one we're going to spend some time on today, show you a few databases that are available to help you with this processes. We have a few, there's quite a few other ones on the market out there, but try to give you some easier ways or some better ways to look at this process and how to get it accomplished in a timely and money-wise manner, so we're not spending a lot of time and effort on this. It says here proactive tasks. There are many tasks in the proactive areas. We just looked at that chart, but asset criticality is one of these tasks. We have to determine how to cost effectively use all the other proactive tasks. And this is one process we found out at the company I work for. You know, we started off doing a lot of things in predictive. We started off doing a lot of these proactive things with precision alignment, with precision balance, precision lubrication. But we found out we can't do all these things on every piece of equipment. So we stepped back and did asset criticality, and we only did certain things on the highly critical equipment. And it was very cost effective and very efficient. So again, I always ask this question, and companies actually ask me this question: why is it important to rank your processes and rank your individual equipment by its criticality to the overall process? Why do we want to do this? Because I hear comments all the time, every piece of equipment in my plant is critical, because if anything goes down, it shuts the entire facility down. Well, that may be true, but there's some examples of factors around that. And one of the examples that I always give is maybe this component here fails and it costs $25 and takes 15 minutes to repair, but another component in your process fails and it takes 24 hours and $100,000 to repair. So which one's more critical? Or if we have a process in our plant that emits a hazardous chemical, if we fail, that makes that one more critical. So how do we know? You know, what are the factors that determine why we would make this statement? You know, what are the other different considerations that we should look at, we want to consider when we ask the question of how critical our assets may be? If we look at this process here, lots of components, lots of things in this process. But which one of these components here, or which one of these different processes here are the most critical? So let's say we go down on the left-hand side of the screen and we look at these rotary kilns. Rotary kilns in this operation are rather large. They're sometimes difficult to align, but a failure of either one of these rotary kilns in this process here cuts their production line in half, cuts their process output in half. So it could have a huge effect. Or if we move over to some of the other ones, maybe we move over to the primary mills or one of these other cyclones, maybe there's capacity there that we can run the whole process with one of those being down. So it makes one of those a little less critical. But sometimes in our chemical processes here, where we're using some acid or caustics, if we have a leak or a discharge of one of those chemicals out of this process, it's going to create an environmental incident. You see in this situation here, they're using cyanide. Very, very dangerous chemical, very dangerous product. But so if it leaves the atmosphere, it gets into the atmosphere, it gets into the groundwater, it can create huge issues and huge effects. So again, different things we have to look at in every one of these areas, and actually each one of these components in this process have to be looked at in these different areas and these different considerations. So again, as I walk into plants, I say, I'll ask a maintenance person, what's the most critical piece of equipment in this process or in this plant? And the maintenance person will usually give me an answer of maybe one or two items. But if I ask other people in the plant, if I ask the operations people, it can be a different process. If I ask a quality or an environmental health and safety person, it could be a different piece of equipment or a different process. So we have to make sure we get input from all the different disciplines in the plant in order to get the correct answer on what is the most critical process or piece of equipment in the operation. So again, we have to get maintenance involved. We have to get operations involved. We want their opinion. We have to get our environmental health and safety people involved. Maybe some quality people. Maybe if you're in the food business, we want to get the food safety people involved. Lots of opportunities here for inputs into your asset criticality. So if I ask each one of you, we won't do this since we're on a phone call, but when I do this in a training, I have people list the top 5 critical assets in your plant. And then beside each of those assets, we list why are those assets critical? What makes them critical? And a lot of times, depending on who the discipline is, whether it's maintenance or operations, they have different reasons for why it's critical. Because operations people are operations oriented, they want things to run. They have to produce product. So a lot of their concern is downtime. Maintenance may be the life of the equipment. Food safety, another, they're going to have different considerations. So there's going to be different reasons why people consider assets to be critical. If we take this component here, it's a 1972 Ford F-150 pickup. And of course, this pickup truck here has lots of different components. So you can see we have wipers and headlights. The pickup truck has brakes and tires. We have a fuel pump. We have an air conditioner. We have a seat belt. We have a windshield. So some different components I've listed here, but which one's the most critical? If you're an operations type person, your number one thing here may be the fuel pump. Because without the fuel pump, we probably don't operate the system very effectively. If you're a safety type person, it may be the brakes or it may be the seat belts. When I do asset criticality training in the mining industry, the number one critical asset on all mobile equipment is the seat belt. Because in the U.S. and a couple other countries, if you get on any piece of mobile equipment and you don't fasten that seat belt, you can be terminated on the spot. So the seat belt becomes the number one criticality on the mobile equipment at a mine. But again, in this pickup truck here, one of the exercises I do is I split groups, my training team's up into 3 or 4 and sometimes 6 different groups. And I have to go through this process here of what component on the pickup truck is the most critical to the least critical. Well, what I find in doing this process is that no group has ever, in any of my training courses in 14 years, no group has ever been exactly the same in one meeting room about what is the most critical to the least critical. And the reason why is because sometimes there's maintenance people in there, sometimes it's all maintenance people, and they're still not the same. But people have different opinions on what makes different components in your plant critical. The same thing with this pickup truck. So again, but one of the questions you have to ask is, how are we using the pickup truck? So let's say we're only going to use it during the daylight hours. Does that make the headlights less critical? It may. What if you're only going to operate it around your facility where it's only 15 miles per hour or 5 kilometers per hour that you're going to operate around the plant? It may make the tires and brakes less critical. I was in a plant in El Centro, California a few years ago where they told me at the plant it only rains here 1 day a year. Well, maybe wipers aren't as critical in an area like that. So again, a lot of times we have to ask the question on our equipment components, how are we actually using the component? How are we using the equipment? Is there redundancy involved? Is there a backup unit? So lots of different considerations are going to come into play when you do an asset criticality on something as simple as a pickup truck. I kept this picture in my training, but how important were brakes here in this incident? I'm not sure how he got over the edge of the cliff, but the only thing holding the pickup truck from going down, and if I've seen this video of this, and it's about a 300-foot drop to the bottom, straight down. And you can see in the picture, the guy's still in the pickup truck. He has to get out. He eventually gets out and gets to the top before the wrecker gets there. But the ball on the hitch of the trailer actually holds the pickup truck, and they actually get the truck out of there. But again, brakes were probably pretty important here in this situation, maybe to keep him from going off the road into that ditch. But look at this slide here. So we have a forklift that drives off the edge of a dock, and it's got a bomb on the forklift. So again, here I asked, what was the most critical component here? Was it the brakes or the seatbelt? Maybe we don't know that the brakes failed, but brakes would have been real important to stop this before it went over the edge of the dike or the edge of the dock. And the other thing, a seatbelt would have been real important in this case here, because without the seatbelt, he ends up as being part of the mast, and it's probably some major injuries. So again, what are the considerations around this? Probably some written procedures that there maybe should have been a truck there before they drove off. But again, some considerations to even a simple task like operating a forklift or loading something with a forklift. A lot of times we have to look at a factor called the cost of failure. And if you take this facility here where this fan, the bearings went out, this fan got somehow loose inside the housing, destroyed the fan. Plant was down for a long period of time until they got the fan rebuilt. But what was the cost of this failure? Maybe that's going to be a consideration if there's only one of these at this facility. What was the damage and how much is it going to cost to fix it? So again, what is one of the most commonly encountered obstacles to good maintenance strategies and practices? Well, sometimes it's getting that input from all the disciplines. Who's in charge of plant safety? I can remember when we did the asset criticality on all the equipment at the facility I came from. We every Tuesday we sat and did this criticality from 1 o'clock till 4 o'clock. And on the first couple, we didn't get much done because I had a safety guy in there, and the safety guy was very objective or subjective to everything that went on there. I was always interested in safety, but I wasn't a big safety guy running maintenance. But again, we had to actually work as a team because we only got 3 or 4 things done in the first 3 hours of the first session. And so we had to get productivities meetings up or we would have never finished the asset criticality. But again, you have all these disciplines with opinions. So it ends up being an emotional decision-making process, but sometimes we have to have some consensus to get an asset criticality accomplished. So what are the goals of a criticality ranking? Well, it's to determine the rank of all the assets by some quantitative assessment and not just personal experience. The assessment must be objective and not subjective, which is, like I said, the one plant in Canada I work with where just the maintenance team sat down and did the asset criticality for the facility. And I could tell right away it was just weighted to what equipment can fail to cause us to be down. They didn't look at very many safety factors. They didn't look at very many environmental factors. And this was a food plant, related to a food plant. They didn't look at any food safety considerations for failure. So not a very good asset criticality. After you get the criticality done, it tells you where to focus your maintenance and reliability efforts in the plant. And again, it creates a baseline that all disciplines can agree to. And I'll show you a report out of an asset criticality, just a test report, but it'll show you how the different disciplines can use the data from the asset criticality. Now, I don't know what the age groups are on the phone call here, but these are 3 major incidents that happened around the world. On the left-hand side of this page is Chernobyl, the nuclear power plant in Russia, where at this facility they ran for around 3 years without doing some of the preventive maintenance and without doing some of the tasks they were supposed to do in running a nuclear reactor. So they operated this plant above 85% capacity for 3 years. In the nuclear industry, one of the PMs or one of the tasks they do is to test the nuclear rods. So monthly, they're supposed to take the nuclear rods and they close them all the way to ensure they isolate. They open them to 100% to assure they open to 100%, and then they go back into control. Well, after about 3 years of operating this facility at Chernobyl, decided they better do this test. The nuclear rods closed all the way, and when they opened them to 100%, they stuck open, which they couldn't get them back in control. Well, that same day, maintenance had one of the main cooling water pumps off and tore down for maintenance, and they couldn't get enough cooling water into the reactor, and they had a meltdown. Around 125,000 people killed, and another 400,000 affected their health, for years after that. BP Texas City in the upper right-hand corner, filling a column, a simple process of starting a column up, turning the heater on, filling this column up. Level transmitter stops at 40%. The operator sees that. He tries to increase the rate. There was a high-level transmitter above the level transmitter that didn't work. So in long story short, the column fills all the way to the top. It overflows to a flash pot, which is a little tall skinny stack on the right center part of the picture. The flash pot's got a level probe in it, which should have lighted the flare and burned the chemical off, but that level transmitter also didn't work, so the flare spewed out liquid out of the top. Some maintenance guys taking a break in a pickup truck down below actually ignited it, and it killed 15 people. Again, critical controls that weren't checked, maybe procedures not in place. The lower left-hand corner of the screen is Bhopal, India. And here, again, triple redundancy devices failed, and around somewhere between 15 and 20,000 people were killed in that incident because most of the vapor from this hazardous chemical went into a village next door and killed everyone in the village. So again, here we have systems in place. Was there an asset criticality done? Did anybody realize how critical some of these assets were and how the procedures were written? But again, thousands and thousands of people killed in some of these incidents partially due to maybe not having an asset criticality done, but surely by definitely not following the procedures set in place for critical assets. I put this slide in here, and I put it in again at the end, just so you have it in your information if you get this as a PDF or a download. But here are some different considerations to look at it in asset criticality. What's the business impact? What is it going to cost for a failure? What's the customer supply impact? Is there a disruption? What's the health and safety and environmental impact? Can there be a fatality if it fails? Can there be an injury? What's the environmental impact? Can you have a release to the environment or to the water systems around your plant? What's the mean time between failure? Does this failure happen multiple times during the year, or maybe it hasn't happened for over a year? How much time does it take to repair it? Does it take a week, a month, or just 4 hours? What are spare parts availability? If I have a failure, do I have spare parts? What's the utilization of the equipment? Does the equipment only run at 30 or 50% capacity? Well, maybe that makes it less critical. Is this a single point failure? And what's the quality impact? How does it affect the quality of our product or the quality of the product that your customer is going to make with it, with this? So again, just a lot of considerations to look at in asset criticality. But here's the ones in the two databases that I have, or the main database I have. You can add more in the new database, but we always want to look at safety issues around a failure. What kind of safety issues can happen? Somebody getting burnt or another issue. Is there going to be an environmental release to water systems, to groundwater, other issues? Is there going to be quality issues with your product? Or, like I said, quality issues with the product down the line. Food safety issues if you're a food plant. Bacteria, allergens. What are some of the production issues that can happen when we have this failure? And what are some of the maintenance issues that relate to the failure of a component or piece of equipment? So we need to cover these basic ones for sure in any asset criticality. So as we look at each of these areas, they can be rated by some method of scoring, and they can also be weighted to know what the effects are going to be in each of these different areas. So as we look at these areas, we'll look at an example database to see how some of these things are going to weigh into your decision-making factors when you're doing the asset criticality. Here's some questions I always ask, or I like to see asked when I do an asset criticality in the area of safety. Can the failure of the equipment or process create a fire? That's one question. Can the failure create an explosion potential? If you're in the refinery business or the grain business where you can have grain dust explosions, a very important question. Sometimes the component may be a safety device. If a safety device fails, the safety devices are on equipment and end processes for specific reasons. Can the failure create an injury or a death potential? Depending on how you rate that. Can the failure create any form of loss potential for the neighbors? And some of my customers, I have plants built right in the middle of cities where there's houses all around the plant. The plant may have been in a outskirts of a city 20 or 30 or 40 years ago. Now it's in the city. So a dust release or a chemical release, like Bhopal, India, having a village built right next door to the plant. And a lot of the people worked in the plant that lived in the village. But again, the vapor went in the village and killed everyone in the village. So here's my cheap database I use, but you can see here it's got these tabs on it. I hope you can see the arrows, but it's got tabs: safety, environmental, food safety, quality, and operations. In the safety tab here, it asks if it's a critical safety device. It asks what the injury potential is. So each one of these have drop-down menus that you can actually change this rating system on. But what's the loss potential? What's the potential for fire explosion? And it gives us 140 rating in the safety area. But safety systems. It says, will the failure of the safety system cause a potential for injury or death? Well, this is an extreme case here where his safety system is a couple of 4x4s or metal pieces here holding the truck in place while he's underneath welding. And it looks like he's welding pretty close to the gas tank. So lots of safety issues here. But if his safety systems fail, there's a potential here for injury or death for sure, and probably some damage to the equipment. Extreme, yes. Here's a tank that was taken in a boneyard at a refinery in Texas. The tank had the pressure relief valve had failed. This tank had blown up. Again, what's the potential for explosion? What can happen to the different components on here to cause something like this to happen? In this case, nobody's injured, but some loss and downtime. And sometimes our safety systems in our shop, we have to look at it. What's the potential here? If something happened with this guy grinding and throwing the sparks right on his acetylene and oxygen tank. It's probably 1 in a million that there might be a leak up top, that something can catch on fire. But I've actually seen this in practice, not only at the facility that I came from in the past, but just a spark like this gets the top of the bottle maybe burning, or maybe the hose is burning. But again, it could be a potential for, I've heard of serious accidents where these tanks have actually caught on fire, have actually dropped over and broke the valve off, and the tank goes shooting across the floor like a torpedo. I saw some pictures where one went through a block wall in a shop. So again, potential for a safety incident. And then always when you're talking about safety, we need to talk about risk. So here's some guys enjoying a weekend, some nice beers, they're sitting in the pool enjoying the cool water. But look at the risk they've taken to have some music in the pool. They've got their plug strip floating on a couple floating sandals. Probably no GFCI protector here. So what's the risk? You have to ask that question. So how many things do we do in our plants sometimes where we create a risk? Now we talk about environmental releases. So what's an environmental release? Well, can the failure create a release to our wastewater? That may get into the city wastewater system. Can the failure create a release to air? Is it dust? Is it a chemical? Is it some kind of a gas? Can the failure of the component create a chemical spill? Always questions you need to ask. Can the failure create an employee exposure? I do a health and safety thing on this where, what is an employee exposure? Well, it can be too hot. It can be too cold. It can be something you breathe. It can be something that irritates your skin. Lots of different ways we can have employee exposure. Can the failure create a community exposure? The plant that I came from, we had ammonia systems there. The prevailing wind from our plant went right into a huge housing development. So if you have an ammonia release, it's going to cause a huge issue for that area with ammonia going through the housing development. Can the failure create an environmental fines? This is one that a customer in Canada, they had made some decisions to put some wastewater into a water retention basin. It ended up costing them about 5 days downtime, a major cleanup effort, and some $250,000 environmental fines because they didn't follow some of the procedures they should have. Can the ferry contaminate the groundwater? I have a customer in Davenport, Iowa that actually contaminated the groundwater underneath their facility for about 20 or 30 years. And I helped a company put in a water system or a cleaning system, clean all that water to drinkable standards before they discharged it into the river. So about 10 to 15 years of pumping water from underground, trying to clean it up. So again, the contamination from the plant created a huge issue that cost them a lot of money. So here we go. We got a transformer fire where we created smoke, maybe for a neighborhood, definitely an environmental release with the oil and smoke here. Here's a tank fire. Again, we don't want to see these at refineries. That's a huge environmental issue. There's probably going to eventually be a spill here and definitely creating contamination to the air. 3 Mile Island. Is there a potential in this situation for some environmental issues, with the river being right next to it, with the communities being downwind? So major potentials here in the environmental area. Here's some wind turbine fires. Again, most of these are out on the prairie, out in the middle of nowhere, but still, we're creating some environmental issues here. Where you can create fires on the ground, we can create smoke in the air in the neighboring communities. And again, in our environmental area here, we have 4 tabs in this area. In the new database, you can put as many tabs as you want, but wastewater risk, we have air emissions risk, we have chemical spills, we have employee exposure risk. Again, in the environmental impact of this piece of equipment, it shows it's an 80. Our total score over here is up to 560, and you'll see how that goes as we move through. But in the food safety area, if any of you are from food plants, can the ferry create a bacteria exposure? Can the ferry create an allergen exposure? Different allergen components that are put in food. How can they get mixed in? Can the ferry create any form of product contamination? Can the ferry create any form of foreign material exposure? From pieces of metal or whatever it might be with foreign material. Can the ferry create any exposure from human context, such as operations or maintenance? So, in the pharmaceutical industry and in the food industry, your maintenance people have to take special precautions so we don't get bacteria inside the chambers where they're actually making or packaging different drugs. The same thing in the food industry. One of the things that my guys had to do when we're making packaging food and you have to work on a piece of equipment, make sure you sanitize your tools, make sure you sanitize your hands. We don't want to get bacteria in the food of the pharmaceutical products. Here's a plant making Gatorade. Again, what's the exposure here of the different products around making Gatorade? If you have to work on equipment or if lids don't seal or just the bottling material. Lots of precautions going around this. In the food business, one of my customers is a customer that just processes grain. All they do is bring grain in, they load grain onto ships and trucks. What's the potential here for contamination? Because these grain products are not only used to make foods that humans consume, but they're also used to make foods that animals consume, and we eventually consume the animals. And if you get contamination of food, can you kill some animals? So again, the food industry and the pharmaceutical industry, very important to talk about asset criticality in this area. So here in the database, we have bacteria, we have allergens, we have contamination from some foreign material, we have maybe some chemicals, and then we have foreign materials. So in this case, the food safety only ranks a 40. What kind of failures can you have around quality? Can the failure create any product quality defects? Packaging, sealing may be some examples. Can the failure create a product loss issue? Can the failure create an on-time delivery issue? Getting your product finished so you can actually deliver it on time. Can the failure create a supply issue? If you're down and you've got supplies building up, or vice versa, what are the areas of quality that can be affected? So here, is this customer here going to have a failure to meet on-time delivery when the ship sunk at the dock and the shipping containers are sinking away? More than likely, there's going to be some issues here. I don't know if all of you on the phone know what demurrage is, but when a ship comes into dock, you only have so much time to get the containers off that ship and reload the ship. If you're out of that time, if you're past that time, you pay something called demurrage. So many times in the grain industry, when you're loading a ship with grain, if a piece of equipment breaks down, you don't get the ship loaded in the number of hours you should, you end up losing money because the ship's there too long. In this case here, they're going to lose a lot of money because these containers are going to be very hard to get off without dumping a bunch of containers off the side into the ocean. So again, some major cost issues here with delivery. Here's what I talked about loading ships, but a lot of times we load rail cars, we load trucks with product. And again, that truck can only be there so long. The truck has to be cleaned. Is there some food safety issues? The rail cars have to be cleaned. So again, lots of issues around quality in our loading, unloading, and processing areas. So here, quality. Is there a potential for a customer loss? Is there a potential for product on-time delivery? Is there a potential for product quality impact, supplier impact? Again, in the quality area here, in this one here, we got a score of 110 in that area. So again, we're building up to this 560 that's on the side here. We talk about operations. What kind of things can happen in operations that are going to affect plant rate? You know, will the failure from operations affect the rate? Will the failure create any downtime? Will the failure create extended downtime? This became something from the company I work with, because in our process, we had enough product we made every day as it shipped out to take care of our customers, you know, with 8 to 12 hours of downtime. But if we're going to be at a major downtime, we were down 24 hours or 2 days, we couldn't service our customers anymore. We ran out of product. And then our customers would go to our competitors to buy that product. And there you run the risk of losing a customer. So will that failure create extended downtime of more than you can handle? Will the failure create operations overtime? You know, another cost factor to consider is overtime, whether it's maintenance or operations. Redundancy. How does redundancy weigh into an asset criticality process? You know, if you keep the equipment operating at full rate, it may have no effect. So let's say you have 10 machines. If one goes down, you can still operate at rate. But this is an example from the facility I was at. We had these flaking machines, and if 1 or 2 went down, we could just speed the other ones up and not affect rate capacity-wise, but it affected the quality of our products. So there were some quality limitations or quality factors that went into a couple of these machines being off. I've been at companies that have 28 plastic extruders making fibers to make material out of, and if 5 of them go down for any reason, it affects the rate of the facility, even though they have all that redundancy. So again, we have to look at redundancy. How are you looking at redundancy? There was times of the year where you may not run at 100% rate. There's other times of the year where redundant equipment may affect the overall rate. Now, some maintenance area issues that we wanted to ask about in an asset criticality. Is the failure a reoccurring failure? You know, does it happen weekly, monthly, or yearly? What's the cost of repair parts? Questions you have to ask. Can the maintenance work create quality issues? You know, the work that your maintenance people do, can it create quality issues on the equipment? Will the failure create high maintenance labor costs? You don't have to use outside contractors, overtime, special equipment. Are those high maintenance labor costs or high maintenance costs? So again, what is the cost of failure? You know, a wind generator, and these happen more often than not just by lubrication and poor maintenance practices. You know, the generator or the gearbox burns up. The cost of failure of something like this is somewhere between $750,000 and $1 million. So what is the cost of failure of your process? Here, just a lube practice. You know, a simple lube practice of plant grease and electric motors. You can see the one in the lower left-hand corner was at a motor shop. The motor failed because of over-greasing. The top one here, not training a new maintenance person well enough. The PM said, take the bottom plug out of the motor and pump grease in until you see clean grease come out of the plug. Well, in this case, not being trained or not using common sense, after pumping a whole tube of grease into this motor and the grease not coming out, it caused the motor to fail. So again, can you have failures just with your maintenance practices? Yeah, possibly. So in the maintenance area, we have this downtime impact. We have maintenance cost impact. We have failure rate, length of downtime, product quality, you know, reduced rate impact. So now we've got our score of 560. We went through all the areas. We rated all the areas with our drop-down menus, and we have a total. So what does that total number mean? Well, depending on what that total number is, after you do all the equipment in your plant, you're going to get a report that shows the highest number to the lowest number. So you can take that criticality rating. You can say, well, everything above 750 is going to be acritical. That could be the top 20% of your equipment. You're going to say, you could say everything that has a rating of less than 300 is C critical. That could be the bottom 30% of your equipment. Everything in between is B. So now we have some data. We've got our equipment listed by A, B, and C. Some of the plants I go to that use the database, they take the top 25% by the rating. They take the bottom 25% by the rating. So the top 25% is A, the bottom 25% is C, everything in the middle is B. So it gives you some way to rate your plant. So examples, plants I go to and do training, I always say when anything above a 750, which is A critical, you would never miss the PMs on an A critical piece of equipment. So all of your PMs will get the A, B, C rating on there. Now, at the plant I came from, at other plants, if we have something that's a PM that ends up in the C critical, we may not even do the PM, or you may turn it over to an operator, because if it's C critical, it means it's less important, maybe causes no safety, maybe causes no downtime. Again, other factors, but if you're tight on time and tight on getting PMs done, you may not do the C critical PMs. Your B critical PMs, you may miss some of those in a cycle. So this is what was set up at my plant. You can never miss a PM on an A critical piece of equipment. Never. You work overtime. You'd use outside contractors. B criticals, you could miss one cycle, but after that one cycle, those PMs had to go back and be completed. C critical PMs, you could miss them 4 or 5 cycles, or maybe even never do them. So a good way to use the data for your PMs. What about when you're starting to do predictive technologies and you ask the question, what predictive technologies am I going to use? You'd figure that out, but what equipment am I going to check? Well, at the plant I came from, in the beginning, we only did predictive technologies on the top 10% of the critical assets. And then as we got those issues corrected and got more time, we moved down to the top 25% of all of our equipment. But that's all we ever did. We only did predictive technologies on the top 25% of our critical equipment by the list. So another method of using the tool effectively. What about if you're making the decision to use synthetic lubricants? With accounting people, they don't want to switch over to synthetic lubricants all at one time because of the cost. But let's say we're going to use synthetic lubricants only on the top 25% of our critical equipment. Another way to use the tool effectively. How do you assign manpower resources? Let's say you have work orders. Work orders need to have an A, B, C criticality. So this sometimes lets you know what work orders you need to get done because it's A critical. What about using your best maintenance personnel or your most highly trained personnel in the top 25% of all of your equipment based on criticality? And then we can develop training procedures to bring the other technicians up to that level. So again, do you want a lower skilled maintenance person working on your high critical equipment? Maybe not, depending on the industry. What about spare parts? This is one of the main reasons that I do criticality analysis of some plants, because they have very poor spare parts storage and they have trouble making decisions. But when I tell people, get the asset criticality done, and we definitely want to have spare parts for the top 25% of our critical assets. It gives you some baseline. Make sure you're covered there. Then you can move down through the B criticality areas as far as you want. So again, another way to effectively use the process. How are you developing your training programs? What are we going to train your maintenance technicians on? So we can develop our training programs around the most critical equipment types. When I go in and do training at plants, when I talk about having training programs and written procedures, and people have to make a decision, well, what am I going to have written procedures for? What am I going to write critical procedures for? Whether it's operations or maintenance. If you do the asset criticality, we should have written procedures for the top 10 or 25% of our critical equipment. How do we rebuild that equipment effectively? How do we maintain it effectively? How do we operate it? Do we need to have operating procedures for some of those critical items? If you go to the military, they have operating procedures for everything. We don't really need that in most of our plants, but on our critical equipment, we need good maintenance procedures, written maintenance procedures. We need good written operating procedures. Very important. What about what equipment am I going to use select suppliers? If you guys remember back when we talked about proactive maintenance, when I talked about the company I work for going out to find out who makes the best motor, who makes the best bearings, who makes the best pumps. Once you find that information out, Do we want to put the best motor on every piece of equipment in our plant? No, the answer is we want to put the best motor or the best components on the top 25% or the top 10% of the equipment in your plant. Should create less failures, longer run times, all kinds of good things go into that, but this gives you a way to select where you're going to put those kind of components. But again, the benefits of this thing, it was a great team building exercise. We had like I said, every Tuesday we met from 1 to 4 with the group, but we all learned something from each other about these different processes, things you didn't realize, things you didn't think of as if you weren't a safety person, things if you're a safety person you don't think about as a maintenance or operations person. So it's a great team building exercise and a great learning tool for your plant. But again, obtain all these inputs. Don't make the decision yourself on what's critical, not critical. Look at safety, look at production, operations, quality, environmental health and safety, food safety. All these areas here have to have an impact or an input into your criticality process. And again, I put this slide in here again. If you guys want me to send this to you as a Word doc, just shoot me an email. But it's a very good criteria around your asset criticality. And the reason I want to put this here is because this is the new ISO 55000 database we have. And in this database, it actually comes to you blank. But I've actually put these factors up here: safety, environmental quality, food safety, operations, and maintenance. And we send this along with there in case you want to use this one. And then like right now, we're selected on the safety area on the slide here. And these are the questions down here that I'm asking about safety. You know, can it cause that fire explosion, safety device? And you put these questions in yourself. So this database you build as you go, it's very easy to use. So the next page we go down here and I've selected the maintenance area. These are the questions in the maintenance area. And each one of these questions then, you can rank them. So in this area here, we're on safety. And in these questions, you can put a drop-down menu. You can rank each question individually and put any number in there you want. So it gives you some kind of a way to weight every question and weight every one of your areas here in the database. And again, very easy to fill in, very easy to use. And the nice thing about this database is the report function. I put 3 pieces of equipment in here, but you can see when the database breaks it down, you see what the rating is of each of your areas for each piece of equipment, and then you get the overall score here. So it'll list the equipment as the highest to the lowest, but then you can also export all this to an Excel spreadsheet and do anything you want with the data. But I think this is very important data. When I've been at plants, now I can send this to the safety guy, and he can say what piece of equipment in the plant ranks the highest in safety, what piece of equipment in the plant rates the highest in environmental, food safety, and so on. So again, very, very easy to use, very valuable process, very valuable database when you're looking at what you're going to do in your facility in the area of asset criticality, building your process around some of these variables. So again, that's our webinar for the day, asset criticality. I put this in there. This is the funky colored software package you've seen earlier is only $375. The custom version where you add the fields, you add the questions, you add the rating system, that one there's only $950. And I can tell you, if you go out and try to buy one of these, the cheapest one closest to this is around $4,000. If you try to build one, you're going to have a lot of time in it. But again, if you buy the most expensive, and we send you the blank one that you can do your own, we also send you the test one there that with all the fields in there. And theirs you can just go in and take out and put in as you want or change the questions. But again, I think all of you can see the value of doing a process like this, you know, when you're trying to figure out where you want to be and where you're at in your process. So again, thanks everybody for joining the call today. We're on for next month again for our next session. But again, we'll have the PDF available if you want to use it. You can also have the recording available. You can download that if some of your people missed this. But again, thanks for being on the call. If you have questions about the thing today, you know, my email address is on here. Just shoot me an email, and we'll get those questions answered right away.